Hi everyone, this is Liam Eagle, Editor-in-Chief here at the WHIR. Welcome to today's webinar. I'll be moderating the session, which is called Protecting Your DNS, Avoid Single Points of Failure, and Ensure 100% Uptime of Your Service, which will include a presentation by John Kane, who is VP of Corporate Services at Affilius. I'll let John introduce himself more completely in a moment. Before that, I just want to give you a bit of an idea of how things are going to work. We're going to save some time at the end for a Q&A period, but you can feel free to use the question submission controls in the webinar software to submit your questions throughout the presentation. And if something comes up, I'll be keeping an eye on them. And if something comes up that's really relevant to what's being said at the moment, I'll try to find a polite point for me to interrupt and put the questions to John. Excuse me. Finally, we're going to have a record of everything that gets submitted, so if your question doesn't get answered in the course of the webinar, if there are a lot of questions and maybe we don't get a chance to get around to it, we'll definitely have someone follow up after the fact. And also, John's information is going to be on screen at the end, so if you want to get in touch with him directly, maybe you don't want to, maybe it's too specific to address in the course of the webinar, you can certainly put your questions directly to him by email or phone or whatever after the fact. So with that, I'm going to turn things over to John, and John, why don't you introduce yourself?
All right, great. Thanks, Liam, for having us today. Again, my name is John Kane. I'm Vice President of Corporate Services at Affilius. And today, as Liam said, we're going to talk really about protecting your DNS, some of the attacks that are currently happening on the network, and maybe some of the things that you can do to either augment your existing network or how you could build out your network to better protect yourself. So a little bit about who Affilius is. For those of you that don't know us, we have 10 years of experience running critical internet infrastructure, probably best known as a domain name registry. We run, .org, the backend for .org, for .info, Mobi, Asia Aero, and a whole bunch of other TLDs and CCTLDs, and supporting over 16 million domains. We have a diverse DNS software network that supports billions of queries each day. And within about the last year and a half, we introduced a managed DNS service that at the end of the presentation I'll spend a slide just talking about that. So let's talk about the future of DNS security. DDoS attacks now occur on a daily basis, and it's not only big corporations that are the victims. Cloud-based services and networks that host them are increasingly coming under attack, whether they're the target of blackmail schemes, sport, just for fun, or attempts to silence, or specifically DDoS users. According to a recent Forrester study in 2009, 74% of the respondents reported that their organizations had been the target of one or more DDoS attack in the past year. In addition, a security researcher estimated that the number of vulnerabilities is expected to double in 2010 compared to last year, so a huge increase. And the Computer Emergency Response Team, CERT, currently publishes information about 2,000 new vulnerabilities in widely used software every single year. Despite being on the front lines of thwarting such attacks, management of DNS services are often overlooked or insufficiently resourced. So to successfully stop the attacks today, organizations need to plan DNS with burstable capacities and extent of the largest known attacks across a scalable DNS network. Unfortunately, this is often a very costly expense. We'll go to the next slide. DDoS, or distributed denial of service attacks, have become the Internet's most significant, widespread, and damaging security problem. In recent years, DDoS attacks have become a virtual cottage industry, with malicious operators offering to rent out their attack tools to the highest bidders. We've seen these for as little as $200, or the cost of an iPhone, that you can rent these botnets out and do a 24-hour attack. These botnets are comprised frequently up to 120,000 PCs within their network. With cheap bandwidth available from home broadband users increasing all the time, the amount of bandwidth available to these attackers correspondingly now stack up to tens of gigabytes per second, and more than enough to quickly overwhelm virtually any web server network. You can see from the charts above that, from the Shadow Server Foundation, that the frequency of attack is high. Hundreds to thousands of attacks occur monthly. This is a problem that, whether it's your organization or our organization will face, and your DNS servers as well as your web servers will be affected. Arbor Networks recently did a study that reveals that DDoS attacks are now the biggest perceived threat by network providers. As you know, DDoS doesn't only affect web servers and applications, but can be directed at your DNS infrastructure itself. So I'll give you just a second to take a look at these slides. And as I said, these slides with the presentation will be available. All right. Arbor Networks survey, if we kind of go through it a little deeper, revealed that DNS attacks are becoming one of the large attack vectors behind flood-based attacks. And the respondents to this survey noticed that application-level attacks, although they're not the largest in traffic volume, are some of the most sophisticated and operationally significant, that they've observed over the last years. When asked if they had observed any trends in attacks moving from brute force to more complex over the last year, 58% of the respondents indicated that they've observed such trends. Brute force against DDoS attacks, secure cell, SSH, and hypertext transfers, or HTTP protocol, were the most common attacks that they cited in this category. What is perhaps the most concerning is the growing size of DDoS attacks. Arbor again revealed that in the last 6 years, the peak size of the largest DDoS attack was over 49 gigabytes per second. I mean, that's just ridiculous in size. Last year's study had the figure of 40 gigabits. I mean, if you look at the size of these attacks, most networks, when they're in-house networks, could maybe take 4, 5, 6. Most folks have not even ever experienced an attack over 8 gigabits, and if they did, in most cases, it probably would have taken them down. The peak attack rate has doubled over the last 6 years and really has no sign of slowing. What does this mean for your DNS operations? It's your infrastructure needs to be massively over-provisioned and hardened to withstand these peak attacks. Later in this presentation, we'll show you some creative ways to integrate diversity into your DNS architecture and help you hopefully solve for this problem. As you can see from this chart, again, from Arbor Networks, the most attacks are long and sustained, lasting for more than 8 hours. This means that not only can large DDoS attacks cripple your DNS network, but it can take you hours and hours to recover, presumably affecting the rest of your customers in the process. So, as a hosting company, you have many unique problems in that you have single infrastructure supporting, many customers. So you'll see it, kind of flood through your entire network. 50% of the providers responding to this study reported an increase of greater than 1 gigabit per second attacks. And these attacks are really designed to exploit service weaknesses, vulnerabilities, and check the back end queries. Several ISP reported prolonged or multi-hour outages. And these target attacks included anything from distributed DDoS, attacking load balancers, and large SQL server backend infrastructure attacks. According to the SANS Institute, attacks against web applications constitute more than 60% of the total attack attempts observed on the Internet. Web application vulnerabilities such as SQL injections and cross-site scripting flaws in open source as well as custom-built application accounts for more than 80% of the vulnerabilities being discovered. Worldwide, there's been a significant increase over the past 3 years in the number of people discovering zero-day vulnerabilities as measured by multiple independent teams discovering the same vulnerabilities at different times. Some of these vulnerabilities have remained unpatched for as long as 2 years. There's a corresponding shortage of highly skilled vulnerability research workers for government and software vendors. So as long as this shortage exists, the defenders will, be at a significant disadvantage in protecting their systems against these zero-day exploits. Security research, has reported in their first half of 2010 that already the number of vulnerabilities found was 89% of the total vulnerabilities found in 2009. So, we are quickly, hitting a tipping point of where the vulnerabilities are, getting past the number of capacity to stop them. In a recent study, above there was the ranking of the top 10 vendors with the most vulnerabilities since 2005. The top 10 vendors are responsible for about 38% of the total vulnerabilities. You can pay specific attention to the vendors likely to be involved in your DNS architecture, such as like Oracle, Microsoft for your DNS or DHCP ranks number 3. Hardware vendors like HP and IBM, at 4 and 6, and router manufacturers like Cisco at number 8. Now, what is the effect to your customers? Especially as I was saying with ISPs, hosting companies. Just as a riverbank, bursting, it can affect every house in the street when it floods. Think about your traffic as it comes through. It can really quickly overwhelm your network, which then has a sweeping effect across all of your customers. So let's talk about a couple of case examples here. In August 2009, Twitter was rendered useless for 7 hours by a DDoS attack. At the same time, users of Facebook and LiveJournal experienced severe degradation of their service. And it later emerged that the target of these attacks were not actually the companies, but rather one of their mutual users who ended up being a Georgian political activist who had angered some malicious Russian activists. Another one, Blue Security. Of course, the absolute worst result of a successful DDoS attack would be the complete destruction of a company's business model and the effective closure of that company. Unfortunately, this scenario is precisely what happened to Blue Security, the maker of Blue Frog anti-spam technology, in the spring of 2006. Spammers reportedly, annoyed at the effectiveness of the company's service, launched a DDoS attack against its domain name, and the attack was estimated to only be about 5 gigabits per second. But this enormous amount of traffic is still less than 1/8 of the largest attack that we saw this year, was significant enough to render and overwhelm Blue Cat Security servers and bring that service to its knees. In order to keep unprotected customers up to date with the status of their service, Blue Cat amended its DNS record to redirect users from its main company website to its corporate blog, which was hosted by TypePad. This redirection, unfortunately, then rendered millions of TypePad users and other 6apart blogging applications, all of them innocent parties, to go down. Within 2 weeks of this attack, Blue Security closed its doors for good. The bad guys had won, and the flood had swept away the whole farm. While most companies widely invest in redundancy for backup, power supplies, web servers, they forget about DNS. A chain, no matter how sturdy, is only as secure as its weakest link. And in many cases, DNS has become that weakest link. Without 100% reliable DNS, it doesn't matter how scalable or redundantly provisioned the system is, because the user may simply never get there. So why introduce diversity into your DNS? Really, without diversity, software or hardware bugs requires waiting for a patch to come. Obviously, you need to QA it and leaves you exposed during this process. Now, without diversity, it can shut down and impact any component until you're ready to fix it. So let's talk a little bit about the 5 dimensions of diversity. The first one is diversity, and I'll go into each one of these as we kind of go through, but diversity of DNS software and providers. Secondly, geographic diversity in DNS node and architecture. Third, a DNS diverse physical infrastructure relying on multiple brands and suppliers. Fourth, multiple connectivity providers for each DNS node. And then finally, which seems pretty self-explanatory, but the diversity in personnel and their expertise. So let's move into the first one. You know, Bind itself suffered from 8 security vulnerabilities between 2007 and 2008. A DNS resolution network running only Bind would have required rolling patches on each occasion, with live unpatched servers running a risk of being compromised during that process. The same applies to any piece of DNS software, whether open source or proprietary. By developing more than one DNS resolution solution, you should either suffer from a security issue. Organizations can simply remove that software from production servers until the problem has been fixed or addressed. Similarly, an organization can limit its risk of its DNS operation going down by adding a secondary DNS provider. With this approach, organizations can successfully have a secondary DNS provider serving as backup while they continue to serve the primary DNS load. This can be deployed by simply setting up a new managed DNS account and inserting one or more of the external provider's name server records for their domain name at the registrar. This method allows the organization to seamlessly fail over to their secondary provider if they're under attack. And in reality, the secondary provider in many cases would continue to provide as an ongoing query, answering queries as during non-attack vectors as well. But this strategy can help you natively integrate your diversity within your DNS software while augmenting it with an external provider. Second is geographic diversity in your architecture node. You know, an earthquake in California, a hurricane in Florida, a monsoon in Mumbai, you know, any of these natural disasters could take out that area's power, internet, and DNS resolution. This could result in your organization's web presence, you know, or entire, you know, electronic communication system being unreachable worldwide if you don't take into account geographic diversity. So Anycast, you know, the DNS master directory, the root server system sits on top of 13 root servers managed by 13 different organizations using 13 different IPs. You know, we've all heard this before, but in reality, the weight of the DNS resolution load is shared between servers deployed at over 180 worldwide locations using an Anycast system. Structuring your DNS network with Anycast allows for seamless failover if one DNS server becomes overload. You know, organizations, you know, we recommend that they should consider Anycast, geographically diverse DNS network, as a significant component of their infrastructure. Next, a diverse physical infrastructure relying on multiple brands and suppliers. You know, the popularity of one vendor's brand of network routers, for example, will make its hardware and firmware a frequent target, you know, for attack. With the diversity of hardware, those routers can simply be removed from the network and fixed, and a fix applied as it becomes available. You know, it's not simply possible with a homogeneous network. You know, in a homogeneous server hardware, represents a similar risk. However, full diverse infrastructure will also take into account the various components of those servers, anything from the CPU manufacturer to the brand of hard disks you run. In such an infrastructure, it would also expect diversity right down to the the power that comes in, to the plugs, to the servers and the walls, interruptible power supplies, and backup generators that power them for emergencies. So from start to finish, having diversity at all levels. Next, multiple connectivity providers for each DNS node. A fully diverse DNS network would build this reasoning into its network on a global level. Each DNS node would be linked by multiple backbones with no overlap between providers at different nodes. This ensures that whether an ISP was hit by a massive latency or clear blackout, that the network would be able to continue to resolve DNS traffic normally. A similar level of diversity would consider when rolling it. A similar level of diversity would be considered when rolling out network operations such as your NOCs. And then finally, a diversity in personnel and experience. I thought this was interesting. There was an article in Baseline Magazine that recently surveyed Wall Street employees, and they found that 58% would abscond with company data if they were fired. What are your policies? How do you have them in place for your folks running your DNS? In many organizations, you have one or even a part-time person managing your your internal, or part of their job is to manage your internal networks. What happens if they go on vacation or they leave your organization? Have you properly documented all of the all of their activities that they do, and do you have someone else trained just in case that happens? Have you have policies in place for passwords, permissioning, access changes when that person is either out on vacation or leaves the organization? More specifically for this group, hosting providers, are limited in security staff to defend these attacks. In a recent Arbor study I mentioned earlier, they took a look at the staffing level issue. Their results clearly show that hosting companies have a deficiency in this regard, with most have little or no security staff to deal with major events like zero-day exploits or DDoS attacks. So building your network with diversity, treat your network, your DNS network, like any other technology. Build your network with diversity. Build it with redundancy, scalability, and obviously avoid, as you can, single points of failure. To deploy DNS diversity across your networks, you can add the components of diversity to your own internal DNS, or you can introduce diversity by adding an outsourced provider. In the next year, you're going to find many changes happening in DNS. Many networks, if you look at your internal DNS infrastructure, a couple of things you'll want to take in consideration. Does your network support IPv6? If not, what changes will be required to allow you to support that? DNS Sac, that's been coming for years and has been talked about for years, but more and more frequently now we're getting requests from whether it's hosting companies, ISPs, registrars, corporations, and even governmental agencies who have a requirement to implement DNS Sac. We're hearing about it more and more frequently. So there are a lot of upstream and downstream issues with DNS Sac, and you'll need to understand how that would affect your network. So why supplement your DNS network? Obviously, it can expand your network with geographic and topographic diversity. It's much more cost-effective, eliminating much of the CapEx and OpEx expenses with doing it. It also, as we said, take DNS Sec capabilities, brings in the high-capacity bandwidth providers, and advanced DDoS mitigation as well. So a little bit about Affilius. When you choose a when you choose a DNS provider, a secondary DNS provider, what are the things that you should consider? Can you work with them in a way that works for you? Do they have a web portal? Do they have an AXFR allowing you to act as a master or hidden master? Do they have an API so that you can integrate this seamlessly into your product or your portal? Do they provide primary or secondary DNS support? In many cases, if you are doing registrar services, you could leverage an API. Affiliates has a REST-based API that securely uses XML over HTTPS. CCTLDs, in many cases, could leverage something like our AXFR, or a DNS zone transfer. So really thinking about the network that you choose and how it could work within your infrastructure to complement what you have or potentially replace it. So I will turn it back over to you, Liam, to see if you have any questions that have come up or questions that you might have.
Okay. I'd like to start with something that I've got written down here, actually, which was while you were talking, I get the sense that you used the DDoS attacks as a great example of a sort of a threat to DNS performance. Are there other significant threats to DNS performance that I don't know about, or that you didn't mention but that are significant?
Yeah, well, there are obviously lots of things that can affect your DNS. It doesn't always have to be an attack. I mean, there are things like they've called it the Twitter effect, or a positive increase in your DNS traffic. I mean, if you had an article written about you, potentially by WHIR, and so many people go to it, and it overwhelms your DNS or your web server. That happens happens frequently, where you see to these large networks that they get overwhelmed because they are not capable of handling the amount of traffic. But yeah, over the years, we use DDoS as one, but there are vulnerabilities that are exposed in in buying software or other softwares frequently. Because they're publicly available, in many cases they are open source software. Just as I said, for sports, some people go in and just for fun say, let me see if I can break this. And after they figure out how to break it, they publish it, and then hackers just will go out there and see how many sites they can take down. So yeah, it's frequent, and many of these are patched quickly because some of these open sources are have a very large support network. But the problem is that even if the patches are available, most organizations are not up to date on the patches, so they remain vulnerable. Even if there is a fix in place.
Okay. Regarding what you were saying at the beginning of that, I was actually putting forth, they used to call it the /dot effect. When
right.
Somebody would write about you, and you mentioned, I was trying to get them to change it to the WHIR effect, but I think you said it's called the Twitter effect now.
Well, Twitter actually had it, the WHIR effect. I use the WHIR effect as the positive article, but it is true that whether it's /dot or Twitter or whatever the latest flood of positive customers coming to your site, it can really cause big problems for many networks.
Well, I just want to say, but before, in case I didn't make that clear a moment ago, we're sort of at the point in the webinar now where we're sort of open for questions. I've got a few here that I'd like to ask that I've got written down, but and I'll get right into those. But if you guys want to submit some questions now, I'm ready to put them to John. So I'll start with mine. But if you guys want to throw any our way, we can certainly handle those too. I guess you used some sort of broad terminology when you were describing the DNS operations of an organization or of a business in general. But I'd love to talk about the sort of challenges that are specific to hosting companies that may or may not relate to other organizations, related to DNS, obviously.
Yeah. Hosting companies, ISPs, registrars, a lot of those face very similar problems. I think the first one is that DNS has typically been free or an included service, for many of their customers. They have a diverse customer base that frequently are price sensitive and don't either understand DNS or see the value in DNS. So that causes problems when you're trying to figure out how to improve your infrastructure. Spend money on something that customers don't see a lot of value in. And because they have this diverse customer base, they also might become, as we talked about the flood, they might become the victim of these malicious attacks. And by that happening, on a single domain or, against their main servers, could have, obviously a tremendous effect on all of their hosted companies and customers. So okay. A little different than an individual corporation might have.
Yeah. I was talking before about IPv6 with folks, and sort of some of the people like Aaron who are sort of promoting IPv6 readiness because that's something that's sort of impending. Do you find that because there isn't necessarily a specific product attached to DNS performance or DNS reliability that's something that is maybe on a back burner for some hosting companies?
Well, I think a lot of hosting companies, were lucky enough to get larger blocks at the beginning. So they might not be thinking about that as an issue today. But the problem they will likely run into is that when they go back to the pot to get more, I think I was talking to Aaron maybe a month ago, and I think they said that they had about 8% of the total IPv4 addresses that are still available. So a very small number of IPv4 addresses are left, and they're encouraging everyone to move to IPv6 because we did the calculation one time and it was a ridiculous amount. IPv6 will allow for every square meter of the planet, like 6 IP addresses for every square meter, including water. So, I mean, a ridiculous amount. It's just such a tremendous amount. It's hard to even comprehend how many addresses are available and how many applications could be used for it. But when you think about it, phones use IPs. Phones could start moving into IPs. IPs could be used for a lot of unique identifiers, and the concept of dynamic IPs will probably, when I say the near future, in the next few years, will probably go away, and folks will move more to static IPs because there are a lot of benefits to static IPs, for hosting providers or for ISPs.
Hey, John, I appreciate that answer. But I was actually trying to sort of compare that sort of concern of readiness and concern of that people aren't necessarily going the lengths necessary to prepare themselves because it's not a product they can sell. I was trying to sort of compare that to DNS and say, is that part of the concern with readiness or with DNS performance, is people don't invest a lot in it or pay a lot of attention to it because it's not necessarily a product you can turn around and sell?
Yeah, I fully agree with that statement. It is another thing to have. It's another resource record type, Quad A records to have in there. And it's also an education to explain to customers, why are these letters in here and why is this different than, in an IP address, it doesn't have letters, they only have numbers. So I think there'll be some sort of an education for customers as well. But all networks are not natively IPv6 enabled. So I think that that's an important one for them, as you go back and look at your infrastructure. That's a basic one. And, I don't see IPv6 as a selling, as a sale itself. I do clearly see premium DNS for, for many customers as a, as an opportunity for hosting companies to move into, and maybe IPv6 or DNS Sac or reporting or some other feature set that you could provide them that adds additional value is worthwhile.
That's actually kind of what I was getting at, and maybe you sort of halfway answered that question, but maybe we can just address it more specifically. Is there a way that improving DNS reliability or improving my DNS performance as a hosting provider can provide me with a revenue opportunity of some kind or something that I can sell?
Oh, clearly. I think that I would suggest that many customers are willing to pay for a premium service, especially if that customer is running a web-based business. You could provide, as I was saying, additional offerings such as an extended DNS network, meaning multiple nodes outside. If you are a hosting company and you only have 1 or 2 or 3 DNS locations, augment that. Bring in 18 locations. If your customer has clients that are international, offer them a mesh that's outside of the United States. Things like failover service, where if your web server was down for some reason or another, that there's a service that could go out and automatically ping their web servers and then fail over to a working IP in the event that something happened. Full reporting suite, where's your traffic coming from? A lot of folks think about they get web analytics, but there's also, where exactly are your customers coming from? What ISPs? There's a whole another element to, to your DNS that you could look at. And I think all of which can help transition the concept from basic or traditional DNS to a premium DNS.
Okay. Let's talk for a moment about the sort of the DNS sort of network architecture. I guess a little more specific about the Anycast concept. If you're running, well, let's say you have 2 locations in the DNS network. Does that mean that's Anycast?
Not necessarily. It could, but in most cases, if they're just running 2 locations, it's probably unicast, in which there's really a one-to-one association between the network address and the endpoint. So a single IP address for each one of those locations. Whereas in Anycast, it's a one-to-many. So I advertise, we'll just say a single, but it could be more, single IP address. And within that, I can have really behind the scene, I run an, 2 to 18, nodes within each one of those meshes. So it's transparent to the customer. They'll just end up going to the fastest or nearest location. Whereas in unicast, you would go to whatever location was the IP address. So it's a lot easier for me to announce or take away announcements for individual nodes. So for example, if my Hong Kong node was running slow or having a problem, or I wanted to do a maintenance on it, I could just take that one out internally out of my announcement without doing anything to my external announcements.
Okay. I guess now in order to improve the DNS reliability or the DNS performance in my network, do I have to, you introduced your 5 dimensions of diversity. Do I have to sort of follow each of those steps, or do I have to, or would just doing one of those things or 2 of those things, would that improve my performance?
I would say doing as many as you can would be beneficial. So, I look at this as kind of like a set of best practices. If you could implement all of these things within your network, that's the list of things that I would do. So one or more of doing those is obviously better, but you need to look at, individually to see, what can your budget afford, what type of internal resources can you dedicate towards implementing and managing this. And you may find that in many situations that the answer is, I don't have a large budget to build out multiple networks. I don't want to add diversification within my own infrastructure. But you could look at a third party and say, I'd like to complement what I have internally with someone like an affiliate or another managed DNS provider, and complement your infrastructure with someone else. And there are lots of ways that you could implement, that sort of a scenario. But it typically works out to be significantly cheaper, and you're doing it with an expert that has not only the resources but an existing infrastructure that you could literally fire up, within days.
So bringing in an external provider such as yourself helps to address all of those points?
And we happen to follow these best practices.
Right.
So Affiliates would meet those criteria. But again, this is a list of what I would consider best practices. But the more you can do, the better, would I guess be the best way to put it.
Okay, so how does somebody go about bringing an outsourced DNS provider on board? I mean, from the perspective of a hosting company.
Probably the easiest way to do it is for the hosting company to act as the master. So if they're already running we'll just say that they're running a DNS infrastructure currently. If they run as the master, so they continue to publish the zone, and then have an affiliate act as the secondary or slave off of that information, it's usually the easiest, most pain-free way to do it. It can be usually done by AXFR or a DNS zone transfer. You could do it with an API or a combination of API and AXFR. The most important thing is to make sure that when you do it with a third-party provider, that the notifiers are in place so that the nodes are that the internal nodes, meaning the hosting company's nodes, DNS nodes, and their outsourced partner, their DNS nodes are in sync, and that they are giving the same answers, because obviously DNS is changed frequently. And normally you would just add in both name servers, within the domain whois record as authoritative name servers. And then not only do you get a quote failover that in case your network goes down that someone's always there to reply, but it also on a day in, day out basis as queries come in augments your network. So you would it would take some extra load off of their name servers as well. It gives them maintenance windows that will have no interruption if they need to do any infrastructure changes or make patches to their DNS. And we found customers in many cases that start that way actually remove their name servers that respond out of it, and they just continue to act as what's then called the hidden master. So they continue to create the zone and keep the DNS running the actual creation of the DNS zone internally, but then 100% outsource the answering of the queries to to a third party.
Okay. I guess when dealing with a DNS provider that is an outsourced service provider, how do I sort of guarantee the performance of that service? What kind of a service level agreement should I be looking for from that company?
Affiliates offers 100% SLA. Any less than 100% SLA, in my opinion, is accepting downtime, whether it's seconds, minutes, or hours per month. When your DNS is down, that there will be some effect felt by your customers. So when you bring in a third-party provider, most of them will have some sort of a service level agreement. The most important component of that service level agreement is the DNS resolution, and as I said, I would make sure that one says 100% on the DNS resolution, because that's the one. Updates and other things obviously are important, but an update won't take down your customer because typically those are not real time anyways.
For somebody like Affiliates or whomever, is it realistic to guarantee 100% resolution, or is that, I mean?
Yeah, and that's I hear that question frequently, and here's the way that I put it. we run the infrastructure for .org, .info, IN for India, a whole bunch of TLDs, and we have to be up and running 100% of the time to support those. Because for any reason, if we went down, the initial DNS query for any of the TLDs that we run would go down, therefore failing that the DNS query down the chain. So yeah, 100% is, but that's why we add this diversity, redundancy, multiple locations, all of the, the 5 levels that we talked about, are extremely important for us, and that's why we developed them.
Okay, and I'm sort of curious, in terms of DNS performance, are there shades of gray? Is it just it's resolving or it's not resolving, or in between? Is there, performing well, performing not so well?
Yeah, there are lots of levels of that, and you'll hear different terms when you say, oh, 100% uptime, and I'll hear DNS providers that say, well, I answered the queries that got to me. So if they're under a DDoS attack and the query doesn't get to them because their pipe was too full, and it timed out, they say, well, how could I answer it if I never got it? Well, it's the, kind of the cart or the horse. They weren't down, but they didn't respond. They're dropping queries or not responding to queries. So those types of things. There are, when we talk a little bit about geographic or topographical diversity, it's really important because there's the whole concept of latency, which is how long does it take for the query to be answered. So if the query has to come from Australia and your DNS, your closest name servers happen to be in New York or in Ohio for that matter, it's a long distance to travel and respond back. So those queries can take, your latency could be 100, 200, 300 milliseconds. And normally you would want to keep that around the 50 millisecond seems to be consensus with the customers that I talk to, fast enough. When you think about, it takes you approximately 80 milliseconds to blink your eyes. 50 milliseconds is faster than you can blink your eyes, so it's not really perceptible. You can get them a lot quicker than that if they happen to be closer, but once it gets down, faster than that, it's, at some level, fast enough is fast enough.
That sounds fast enough. That actually sort of raises a question that I also had down here about geographic diversity. Are there sort of ideal locations geographically for DNS nodes?
Yeah, well, it depends on the company and what their client base looks like. So normally I would suggest 2 locations to 3 locations just to be able to have the diversity within their own infrastructure. Now, where those are done, sometimes it matters where. Don't do them. There are some don't do's. I wouldn't do them on the same power grid. I wouldn't do them in a region that that frequents with large storms. So I wouldn't put both of them in Florida or on the on the same seaboard. Just from a the potential that something could be taken down. You wouldn't want 2 of them sitting essentially in the same city, on a fault line. So normally I would say multiple locations. If you happen to be looking for geographic diversity around the planet, go towards larger locations. There are cities like Amsterdam and Hong Kong, and Miami for the U.S. takes a lot of traffic through the NAP for Americas. D.C., New York. There are a lot of Texas is on its own power grid. So there are a lot of good locations to put it, but look to see how close you are to the local internet hop. And typically that's where all the customers are going to be anyways. So they're going to be the largest ISPs there, and that's likely where I would locate. The other thing I would make sure is that they have, obviously all of the power redundancy that you would expect, and multiple bandwidth providers. And when you implement in your nodes, make sure that you've have multiple bandwidth providers at each one of your nodes, so you at least have diversity. So if one of the large networks had a problem, that it's not touching you in 3 of your locations.
Okay. Within my own DNS infrastructure, is Bind the best software to be using, or is there a better alternative?
Well, Bind is the most widely used and probably the best support community. It's open source, so there are a lot of patches that are done and relatively quickly on those. But there are others. There are typically 4 solutions that I see. I see Bind, I see NSD, which is NL Labs. They seem to have a pretty loyal following out of the Netherlands. Power DNS is another one. It's a little slightly different. It's a database-backed DNS software, so it makes it preferred by customers in some instances. And then obviously we'll see homegrown solutions, folks that will either take an open source and kind of tweak it for their own needs, or I've even seen some that have built DNS software from the ground up. If I was to recommend, I think Bind is probably, as I said, the largest and the most widely used, and probably a good, a good solution for many organizations.
Okay. Well, John, that's all the questions that I have laid out here. We're a few minutes shy of the hour mark. I don't know if you think you maybe. Oh, actually, you know what? I did mean to ask something else here. So I started to wrap up, but I guess in terms of looking to the future, in terms of DNS, are there new developments or things that are on the horizon that we should be looking for?
Yeah, we mentioned this briefly in some of the other things. The biggest thing that I think I would keep an eye out for is DNS Sac. It's going to be the next thing for the next 12 months. The zone is actually going to be signed within the next week. Many more TLDs, affiliates signed .org on behalf, for PIR. You'll probably see many more of the 15 other TLDs that we support signed over the next year. And then, as I was saying, there'll be best practices and mandates. .gov is already requiring that any gov domain is signed. There probably won't be those requirements in any of the generics, such as com and net, but those will be signed in the beginning of next year. So you'll see a lot more around it. Hosting companies will probably hear the question, how are you going to support this? What are you going to do? What are the costs going to be? And that's where, I would take a hard look at, if I was to say, I would take a hard look at their infrastructure as it exists today. If they have, questions or concerns about it, my contact information is up on the screen. Feel free to contact me directly or any of our sales associates, and we'd love to talk about, ways that affiliates could help them out.
Okay. Well, I am now proposing that we wrap it up. What do you think about that?
That's great. Yeah,
okay.
Appreciate it. A lot of good questions.
We're a few minutes shy of an hour, but I think we've got a decent bang for your buck having delivered here. Before we conclude, I'd like to thank everyone for attending, and of course, I'd like to thank John for a great presentation, some great information. And I'd like to let everyone know that an archived copy of this webinar will be going up on the WHIR website sometime next week. It'll be posted along with all of our past webinars at thewhir.com/webinars. Thanks very much to everyone for attending, and thanks again, John. Have a great day.